All right, here's a second quick little video just to go over completing the square with you. So if you have something that's a perfect square trinomial, what ends up happening is this number here, and my pen isn't working. Uh-oh. Give me 1 second here. See if that worked. Yeah, there we go. Sorry about that. So if this number here, this number is actually just 1/2 of this number that is then squared, and that's what I wrote right over here. If that's the case, it's a nice perfect square trinomial. Now, not everything we come across is going to be one of those, but we can complete the square in order to make it be a perfect square trinomial. So let's take a look here. We have the function here, x squared plus 6x. All right, what we want to do is draw this out graphically. In fact, original old mathematicians and stuff like Newton and stuff, they didn't say what is 3 times 5. They'd say something like, what is the rectangle of 3 and 5? Because that's what multiplying those together did. It told you the area of the associated rectangle. And so they thought about everything very geometrically with a lot of shapes and stuff. So if we look here, we have x squared. Well, what I can do is see that as an x times an x, which would be this x squared. It'd be the area of a square that had one side of length x and the other side length x. I can look at the 6x and say, all right, this is the area of a rectangle where one side is length 6 and the other side is length 6x, and therefore we have an area of 6x. All right, and so it's x squared plus 6x. We're like thinking of those as areas instead of just, unknown numbers. I can then take and go in the next step. I can leave this first square alone. It's still x squared, but I'm going to take and split that second rectangle in half. That way what I end up with is a 3 times x here, which gives me an area of 3x, plus a 3 times x here that gives me another area of 3x. And so 3x plus 3x is this original 6x, so all I did was split it apart. Okay? Now what I want to do is I want to take this first rectangle and I want to put it right here on the edge, which is what I did right there. I just put it right up against the edge of that other one with its side x up against there like that. Then I'm going to take this other rectangle and I'm going to rotate it and I'm going to put it down here along the bottom, which I did right there. And that then gives me something that is almost a square. We have 3 plus x along this length and 3 plus x along this length, but we're missing, right down here in this little corner, we're missing this little corner because it's only x on this side and only x on this side. So what we want to do is look at, well, what is the size of that little missing corner there that I did in red? What would that little missing square be? Well, if we look at it, this length on this side here is just the same as this length, which is 3, and the length on this side is the same as this length, which is just 3. So it's a 3 by 3 little square. And so if I could get a 3 by 3 little square and actually put it in right there, then this would become a 3 right there and a 3 right there, and then this would be x plus 3, 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 and we would have a square because all the sides would be the same and they're all at right angles to each other. Now, doing this in practice, if I'm going to add in a 3 squared, I have to also then subtract it. I can't just add 9 on and have it be the same equation, but if I add that 9 and subtract that 9 at the same time, or whatever that area is supposed to be, then that's a legal thing to do. So let's take a look at this example here. It says solve by completing the square. So I drew it on the left in pictures, and on the right I did it just in the purple there, just in math. So you can see I started with my square x plus x, or x by x. Here's my x by 10 square. I still have a plus 8. I mean, I guess I could have made a 1 by 8 rectangle or something, but I didn't really need to for that. I then split this rectangle down into a x by 5 and x by 5. That's that whole part up here we talked about dividing it by 2. And then I move it and rotate it around to make this almost square, but we have this one little missing piece. That missing piece is this length by this length. So it's a 5 by 5 little square. So I add a 5 by 5 square onto it, and then I also subtract a 5 by 5 squared. So I'm adding 5 squared and subtracting 5 squared. That's like add 25 plus 25. That's the result of adding 0, but it's going to put it into a better form for us. Okay, so that's what I do there picture-wise. So what I did over here is I did the same thing, but I did it x squared plus 10x plus 8. There it is in an equation. Here I made it x squared plus 5x plus 5x. So 5x, 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 like that. Then I went to the next line where I looked at this and I said, hey, this is an x plus 5 by x plus 5 square. So that's x plus 5 squared. That's this square right there. And then I still have, since I made that square by adding on this 5 squared, I have my subtracted 5 squared right there. So this subtracted 5 squared is this 5 squared right there. That subtracted 5 squared. And then plus 8. You then move everything over to the other side by subtracting 8 and adding 25. You get x plus 5 squared equals negative 8 plus 25. That gives you x plus 5 squared equals 17. And then you can take the square root of both sides. So you get x plus 5 equals plus or minus square root of 17. Don't forget your plus or minus when you're square rooting like that. And then you can subtract the 5 over, and you get x can be either negative 5 plus the square root of 17 or negative 5 minus the square root of 17. Okay, so there's an example for how to do it. Now, once you get good at this, you don't have to draw these pictures in every time, but if the time comes and you're like, oh wait, I can't remember what exactly I was supposed to do, hopefully this geometric picture of it helps you to get through it. Over here, I did another example for you here. You can read through that. I didn't draw the pictures here. Because I had just drawn the pictures, all I did was I took this number right here, I divided it by 2 and squared it. And I did the same thing here for y. I took this number here, divided it by 2 and squared it. And then I did that for both x and y. So that's completing the square for both x and y right there in order to get back up to the standard form for a circle. And after that, it was just a matter of going through, lumping terms together, see that I end up with this is 8 over 2, that gave me that 4, so I got that y plus 4 square, and I got this x minus 3 square here, and then I combined all these other constants together that I had to subtract off because I either added them or subtracted them over there, gave me a negative 15, and then ultimately I got our nice standard form right there where I could then read the center and the radius off of it. Okay, hopefully that helps. That's it for this little video. Go back, watch it again if you need to, pause it, think, rewind, listen to it again, and then let me know if you still have any trouble with this. All right, that is it. Thank you.